B class examples. So I'm going to getting into some B class examples where we do some more and more complex calculations. Okay, let's move to some B class examples where we'll do some more bigger size ranges. So I'll get into one example with B class. So my requirement is using any B class address, any B class, because the calculation for any B class remains the same. I need a requirement of 1000 host addresses. So 1000 host addresses, and if you remember, by default A class supports 16 million addresses in one network, B class supports 65,536 addresses in one network, and C class by default supports 256 addresses in one network. So anyway, C class examples we did already, it's the calculation. So now we are going to do our B class examples where we need to divide a default size of 65,536 addresses into small networks such that each and every small network should get a requirement of 1000, 2000, 4000, whatever the size. The calculation process goes the same in all the B classes. The only difference is the range will be varying as per the example. Anyway, in the real networks, probably it's very difficult to find 1000 hosts in one network. So probably, but here we are just getting into some more in-depth of calculations. So let us try to how to find the range for bigger numbers. So this is very useful, especially when you are getting into some advanced routing concepts where we get into some summarization, all those things, or even in the certification exams where you may be tested on some of these calculations. Okay, not exactly calculation, but you'll be asked some questions, bits, some multiple choice questions where you have some more complex calculations with a bigger size requirements with A class or B class. So we are going to understand how exactly it goes. The almost 70-80% remains the same except few changes. So the first thing is we need to go with this formula 2 to the power of h minus 2 greater than or equal to requirement. So here my requirement is 1000. So as per this 1000 requirement, which value satisfies my condition? So I need to consider 2 power value. So here if I take 2 to the power of 9, 512 not going to satisfy my condition because my requirement is 1000. So if I take 2 to the power of 10, I think it's enough. So which means I don't really need exactly, we cannot divide 1000 addresses, but the possible size is 2 to the power of 10, which is 1024. In the two addresses we cannot use the first and the last address. So which means total I can use 1022 or your valid host addresses, which I can assign to any number of devices. So the first step is finding out how many host bits are required. So as per this example, how many host bits are required? I require only 10. So this is your required host bits, so which is your 10 value. So now the next thing we need to convert how many converted bits, or we can say how many bits we need to convert into network. So we are talking about B class. So B class supports 2 network portions and 2 host portions. So which means network remains the same, nothing but if I write network portion into binary 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8 second portion, and if I write host portion 1 2 3 4 5 6 7 8, so 8 host bits, and then 1 2 3 4 5 6 7 8. So which means B class supports 16 network bits and 16 host bits. So this is the slight difference which we find from B class to C class. In C class we are taking 24/8. In our B class we are going to take 16/16. So now if I just count out of this 16 host bits, you can see there are 16 host bits. Out of this 16, I don't need exactly 16, I just need only 10. So which means 10 bits as host, that is enough for my requirement. So I'm going to leave 10 bits, which means 8 bits already here and 10 bits here. So host bits I require only 10. Remaining 6 I'm converting, which means 1 2 3 4 5 6. So I'm converting, or we can do like this, 16 minus 10 is equal to 6 bits gets converted. So total becomes how many? Total becomes, by default there are 8 bits, and I'm converting only 16 bits, and in the fourth portion there is no network bits. So which means we need to write just 0. 0 represents host bits. So there are 8 host bits here, 2 host bits here, total become 10. So total becomes, by default there are 16 plus 6 extra added, so it becomes 22 total bits. So the tally of 16 changes to 22 network and 10 host bits. So this is same as what we did in our previous examples, no changes except slight change in your requirement number of host bits and network bits. So in case if you want to find out how many small networks I get, you can simply convert into 2 to the power of n value. N is your extra bits, the converted bits, so I can take 2 to the power of 6, which means I can get 16 subnetworks. I get exactly 64 subnetworks. 2 to the power of 6, it becomes 64 subnets. Now anyway, if I divide into B class, I get exactly 64 subnet. Okay, so if you find the subnet mask is the same thing what we wrote here. You can see here 8 bits means it's 255. 8 bits if you add 255, 6 bits if you add, it becomes 252. So you can refer this table here. The table will give some idea on if you add 6 bits, 6 network bits, which means 128 plus 64 plus 32 plus 16 plus 8 plus 4. Anyway, if you add, it becomes 252. So no need to add. This is the subnet mask what we get after dividing. Okay, so if I want exactly 1024 addresses, I have to use this subnet mask. So till here, the calculation is almost the same except a change in the number of network and host bits. That's the only difference, and remaining all is the same like what we did in our previous C class examples. Now the last thing is writing the range. Now when you're writing the range, we write always based on 2 to the power of h value in general. So 2 to the power of h value is 2 to the power of 10 bits. What we got, 1024 is the size of a network. So which means group of 1024 addresses will be one network. So now if I try to write the range, any address, let's say 17.16, I'm going to use any B class example. So the first range, by default we start from 0.0 and we write 0.1 and we write 0.2, like that I write up to 0.255. That is the maximum number I can write in the fourth portion. So 0.255. So I'm going to write the complete 0.x. X represents all the numbers starting from 0 to 255. So I get only 256 addresses. But my requirement is even much bigger than 256 addresses. So I cannot write 0.256 because there is no address in IP address with 256. So I cannot write this. But the continuation address for this is, what's the continuation address? 1.0, 1.1, 1.2, like that I go up to 1.255. So I'm going to write the complete 1.x also, which again, how many addresses? 256 addresses. So total becomes how many? 256 and 256. So it becomes 512. So again, this range is also not enough to meet my requirement. So I need 1024 addresses. So which means I have to continue. So the continuation address I'm writing here, just a continuation here. So continuation address will be 2.0, 2.1, like that I go up to 2.255. So if I write the complete 2.x, which means if I write the complete 2.x, so I get exactly 256 addresses. So total becomes how many? 768, because 256 here, 256 here, 256 here. Okay, so it becomes 256, 256, 512, 512 plus 256, 768 addresses. Which means if I count from 0.0, 256, 256, 256, 768 addresses. Still it is not enough to meet my requirement because my requirement is much bigger than 768 addresses. Which means the continuation address is 3.0, 3.1 till 3.255. So I'm going to write the complete 3.x, which is again 256 addresses, which means it ends on 1024 because plus 256 becomes 1024. So which means if you want to write exact group of 64 addresses, now coming to our range. So when I'm writing the range always written based on 2 to the power of h value, and h value is 1024, which means my range ends on The range starts on 172.16.0.0 is the first range. So if I take 172.16 network, 172.16 network, and the range starts on 0.0 and ends on 3.255. Means if I write any address in between 0.0 to 3.255 will be group of 1024 addresses. So it exactly 1024 addresses, which means the next range starts on 4.0. The next range starts on. So this is one network. This is one network. So probably here, this is the way we had to write the range. But again, this is the way we calculate in general. In general, if I consider 0 dot all, if I write all 0 dot x addresses, I get only 256 addresses, which is not required. If I write 1 dot x also, I get 256. So it becomes 256 plus 256, 512. If I write 2 dot x also, it becomes 768 addresses. If I write 3 dot x also, I get 1024 addresses. Means in order to have 1024 addresses, I need 4 blocks. So I can represent this as one block. 0 dot x, 1 dot x, 2 dot x, 3 dot x. Exactly, I need 4 blocks of addresses. So if I represent each block as a group of, if I just represent each block of addresses as 1024 addresses. But again, it is a little bit lengthier method of calculation, because if you see here, this is a little bit lengthier, because going like this, finding out the range in this method, anyway, it's a very good way to understand. But once we understand, probably we really don't want to calculate in this format. So to do this, I give one simple, easy shortcut method for writing the range for bigger numbers. So whenever you want to write the range for bigger numbers, always use this formula: 2 to the power of h divided by 256. So what is the 2 to the power of h value in our requirement? It's 1024. So exactly 1024 addresses. Each block represents 256 addresses, which means how many blocks I require in order to support 1024 addresses. So I get exactly 4. You don't really need to use any calculator also for this. You can just make it as a round figure value. If I just make it round figure as 1000, if I make it as a round figure of 250, in 1000 I get 4 250s. Similar way, in 2000 I get 8 250s. In 4000 I get 16 250s. In 8000 I get 8 4 32 250s, like that. So probably it's an exact division. You don't get any decimal values like points. Exact 4, which means I need 4 blocks of addresses. How many blocks I require? 4 blocks. So I'm going to use 0 dot x block, 1 dot x block, 2 dot x block, 3 dot x block, which means if I start from 0 dot x and if I finish on 3 dot x, I get exactly 4 blocks. Total becomes 1024 addresses. So what I can do is I can increment plus 4 here. Increment plus 4 in the next portion. Don't increment on the last portion, because if you increment here, it is wrong. Because if you increment there, it is just adding 4 addresses. I'm not talking about 4 addresses. I'm talking about 4 blocks of addresses, where each block represents 256 addresses. So plus 4 here will simply solve your problem. Plus 4, plus 4, plus 4, like that it will go on. No need to write all. I don't really recommend to write the complete range, because if you go on write, you get 64 subnets. So anyway, we know that exactly I get 64 subnets. Probably you just write down 3-4 ranges, and finally if you are writing from bottom to top, I suggest you to subtract from 256. If you subtract 4, this is the last range, and ends on 255.255, and this ends on 7.255, and this ends on 11.255, and this ends on 15.255. So like that, this is one network, this is second network, third network, fourth network, fifth, sixth, like that. You get 64 subnets. So in this example, there are 2 things we learn, and 2 things slightly different when we compare with the previous C class examples. So in this example, you'll get a more better understanding on how to do a B class example. If you're doing any B class example, we have to take 16 network bits, 16 host bits, because by default there are 16. And based on that, we have to find out the number of host bits, number of converted bits, like that. That's the one thing we need to keep in mind when we are working with B class example, and remaining all the steps are same what we did in a previous class. And the next thing is, whenever you are writing the range for bigger numbers, anything more than 256. 256 or more than 256, because if I take a normal 256 size, I need only one block, which is similar to P class. Anything greater than or equal to 256, always remember, I suggest you to use the formula of 2 to the power of s divided by 256. Based on that, you can find how many blocks are required. Based on that, we can easily write the range. So anything less than 256 usually not required, because less than 256 means it's very simple, because it will come in the fourth portion. Anything less than 256, always we increment on the fourth portion, and anything greater than or equal to 256 we increment on the third portion, because the size of the network goes beyond 256. So we need to increment on this part. Okay, so this one example will give some more idea on how the B class calculation goes. So probably I suggest you to just work on some more B class examples. Like we can do some exercises on your own. You can take any requirement, like you can take a requirement of 500, one example, and even you can take a requirement of 200 host. The next example, 200 host, and you can take a requirement of let's say 4000 is the requirement. So like this, you can probably work on some 2 or 3 examples to have some more clear understanding on the calculation process. As already said, the more you work on this type of calculations, the more you have a easy and clear understanding on this. Okay. So similar way, I got one more example in our workbook. You can see here requirement of 500 host. If you have a requirement of 500 hosts, probably the size of the network will be 512. In the 2 addresses, we cannot use network ID, broadcast ID. So which means 510 or valid addresses. And whatever the power value we get, that is your required host bits. And whatever the converted bits, you can see here total bits are 16 in B class. In that I just need only 9, so 7 gets converted. So based on these 7 converted bits, I can find how many subnets I get. 2 to the power of 7 is 128 subnets I get. And valid host addresses is 510. The same thing what we did here already. And the subnet mask will be /23, which means 8 plus 8 plus 8 plus 8 plus 7 plus 0. So it will be 255, 255, 255, 254. And it will be multiples of 2, because the size of the network is 512. So 512 size means I need 2 blocks. So it will plus 2, plus 2, plus 2 here. Like that you get, if you go on right, you get exactly 128 subnets. So similar way you can try other examples as well. Like the examples as that you can take 200, 2000, 4000, any size you can take. You can just really work on some examples to have some more easy way to get some enough practice on the examples.